Yeah. Good evening, everyone. Switch on your cams. Let's start off. So last class we have done with this. Now in this, I can ask you one more theoretical question. Let's say if you have a test tube which is rotating with omega, and let's say if I have some air bubbles, and let's say we have some sand particles or something which are heavier. So when this thing start rotating, can you tell me where will the sand particles go and where will the air bubbles go? I'll give you a hint. See, think about your washing machine. When your washing machine rotates, where will the clothes go? Where will the soap ka foam go? Ever observed that soap ka foam? The foam comes to the center. The clothes go and stick to the edges. So what will happen here? So when this thing starts rotating, what will happen to the air bubbles? So once this starts rotating, so think of like this: the centrifugal force is kind of like gravity. That's what I told you. So air bubbles will float opposite to gravity, right? So the lighter ones will come toward the center, and the sand particles will accumulate here. So denser particles go away from center. Lighter particles or less denser ones materials with density less than what liquid will go opposite to the centrifugal force. We will see about this again in fluid mechanics. Clear? Have a look at this. Others do keep your cams on. Next thing, non-uniform circular motion. So till now we dealt with the particle is going with a constant speed. So non-uniform is really not that different, except we again add up one more thing. So in a non-uniform circular motion, Sharman, you need to put your cam on. The message. Okay. So what happens here? The speed of the particle is not constant. That's it. Straightforward definition. What is uniform circular motion? Speed is constant. What is non-uniform? Speed is not constant. So speed of the particle going in a circle is not constant. So this particle, right, has two accelerations. Yeah, if your cams are not on, you'll be kicked out from the classroom in a minute. The particle has centripetal acceleration.
Sir, this is my mobile.
You know, Vihan, you thought you come like twins. You're an expert in making people confused. Next time, put it Vihan 1, Vihan 2. Or Vihan clone. Chalo. Chhod dena, this looks more weird. Switch it off. There are two people. The particle has centripetal acceleration, which is responsible for making it go in a circle. That is, this helps in changing direction. That is what we have seen in the beginning in uniform circular motion. And now, also on top of it, we have an additional tangential acceleration. Right? This is responsible for changing the speed. Makes sense? So when a particle is going on a circle, this is what you will notice. You will have one acceleration, a tangential, and now you'll have one more acceleration, a centripetal. So the net acceleration will be somewhere in the middle. So the difference between uniform and non-uniform, right? The only additional thing is now we have an extra acceleration which is responsible for changing your speed. So a tangential, this we did study in the beginning in circular kinematics. This is nothing but rate of change of v tangential. Right? This can be also written as v tangential, dv tangential by ds, just like your kinematics. And if you remember, we derived this a tangential is nothing but alpha bar cross r bar. So that is simply a tangential is r alpha, where alpha is your angular acceleration. We never used it because in uniform circular motion, this term always used to be 0. And as usual, what is a centripetal? A centripetal is your omega square r. Right? And what is omega? Interestingly, omega is nothing but alpha is d omega by dt. So they are related in a way. So if you want to find the net acceleration, since both are perpendicular, it will be root over a centripetal square plus a tangential square. Let me show you an example. I think that will make things more clear. So there, these are the main ones. So we have, this is all a tangential. A centripetal you already know. This is a net. So in non-uniform circular motion, now we're dealing with one more additional acceleration. So think of like this. Do you remember how we derived it? We said a is equal to u square by r. What is the meaning of that? If you want to go in a circle with speed u, then you should have an acceleration u square by r. Isn't that how we proved it? What if your speed is changing? So if your speed is changing, then your a centripetal also will keep changing, isn't it? So if someone is changing with increasing speed, then you also have to provide more and more, centripetal acceleration to make it go in a circle. Let me show you a question with an example that would make things clear. Any doubts on this page? So in a non-uniform circular motion, the particle will have two components of acceleration. One is responsible, the centripetal is responsible for changing your direction. The tangential is responsible for changing your magnitude. So let me take you an example problem and let's see from here. Consider a vehicle starting from rest, with constant tangential acceleration. A. A is the constant tangential acceleration. So I want to find the speed, find A centripetal, find A net, find the frictional force. If you're going on a circle, someone has to take you forward. So there is a frictional force which is helping you. Frictional force on the vehicle at time t. And if mu is the coefficient of friction, meaning literally I'm dumping everything here. If mu is the coefficient of friction, find time when the vehicle slips. Think about it. If the vehicle just keeps on going faster and faster and faster, at one point, your friction cannot give the force that is required and you start slipping. Find the time when vehicle slips. You want to try for a minute? Try, give it a try for 2 minutes and then I'll show you one anyways. But you give it a try, whatever you think you do it. We'll do it as a problem only. Like I said, for the speed and all, you can just use a regular kinematics. Since A is constant, you can use V is U plus AT, S is UT plus half AT square, all that stuff works. Let me help you with this. See, maybe there is a catch here. Listen. So first thing here, forget about all circular motion and all that stuff. Just think of like this. You have a vehicle here. Your speed is 0. Your tangential acceleration at is a. So you're going in a circle like this. So after some time, you'll reach here and your speed is v. So what you did was indirectly, you're treating this entire circle like an x-axis, isn't it? You're going in a kind of like a line, meaning the equation look like that. So v is equal to u plus at. Your initial velocity is 0, so v is equal to at. Done. You got your speed. What do you want to find then? Centripetal acceleration. What is a centripetal? A centripetal is v square by r, which is a square t square by r. What else you want to find? A net. What is net acceleration? So at this instant, understand this thing has two accelerations. One is your centripetal acceleration. One is your a tangential. So this vehicle is having two accelerations. And both are perpendicular. So a net would be root over a centripetal square plus a tangential square, which is a centripetal square will be a power 4 t power 4 by r square. A tangential is a square. This is your net acceleration. And this net acceleration will be somewhere like this. So they can ask a question like this. In a non-uniform circular motion, how is the acceleration? It is not towards the center. Getting it? In uniform, it is always towards the center. Here, it is not towards the center. So if I want, I can even find this angle here, theta. So tan theta would be simply a centripetal by a tangential. So theta is the angle between net acceleration and velocity. So I can even ask you the angle here. What else do I need? Now tell me one thing. If this was your net acceleration, who is providing this acceleration? You can't get acceleration just like nowhere, right? I told you this. You are going in a circle because there is a force. You won't get a force because you're going in a circle. So when you're here, the net acceleration is something like this. If you see, the only force which can provide the acceleration is friction. So friction is the one who is providing the both a tangential and a centripetal. It is playing the role of both. So friction has two components. One is providing centripetal and one is providing tangential. So friction provides a net. So how much is the frictional force? F is equal to mass into a net, which is m into root over. I will just leave that a net there. Now the second part, he's saying at what time will it slip? And I know friction is always less than equal to mu mg. You cannot exceed this value. M gets cancelled. So a net will be root over a power 4 t power 4 by r square plus a square must be less than equal to mu g. Square it on both sides and bring t power 4 on one side. So we will end up with t is less than equal to mu square g square minus a square r square by a power 4 ka root. Up to this time, the vehicle won't slip. This is your no slipping condition. So once you cross this time, the vehicle will slip. So what is the whole story happening here? See. So when the vehicle started, let me show you. I'll get back to this page. Have a look at this. Let's try to draw a few things here. Suppose if I'm drawing accelerations here, how will the acceleration look like? So when you're going in a circle, this was your a tangential. When you're here, this was a tangential. And if you see, the length will remain constant because a is constant. This is a, this is a, and this is a. But look at a centripetal. A centripetal here was 0. Here A centripetal is like this. Here A centripetal is little big. Here A centripetal is pretty big. Here A centripetal is even larger. Basically, as time passes, A centripetal becomes bigger and bigger and bigger. The reason? A centripetal is V square by R. And what is V? AT. So A square T square by R. So A centripetal is increasing in magnitude. The vector becomes bigger and bigger and bigger. So if you look at A net will look like this initially. Then A net will look like this. A net is also becoming bigger. Then A net will look like this. Then A net will look like this. Are you getting how's the diagram? So as the vehicle is going, you can see the green one is the centripetal, red one is the tangential, and the black one is the net acceleration. So that is how the acceleration profile will look when this thing is going in a circle. The more it goes in a circle, it requires more and more centripetal acceleration. At one point, friction cannot give that much, it starts slipping. Is that making sense, everyone? So as time passes, friction requires, you require more and more force to make you go in a circle. This is the acceleration profile. So in non-uniform circular motion, the net acceleration will not be towards the center. In this problem, it is actually increasing in magnitude and it is becoming bigger and bigger. Now, suppose same diagram, if I ask you to draw the friction car diagram, how will friction look like? If you try to plot the frictional force acting on this, remember just now we said F is nothing but ma net. So initially at T0, the friction is actually tangential. And then here the friction is, it would be something like this. Basically, it will be in the direction of net. This will be in the direction of A net. When you are here, this is your A net. And when you are here, this is your A net. The A net is becoming bigger and bigger. So your friction also will become bigger and bigger. So your friction also will look like this. Friction is making an angle. This is the center. This is the tangent. I think now it looks more clear to see. This is the center. This is the tangent. Center, tangent. The frictional force is also rotating. Frictional force is also changing. So once you reach Fmax, you skid. Is the force car diagrams clear, everyone? So in a uniform circular motion, your friction had only one job to do, make you go in a circle. But in non-uniform friction had two jobs to do. One, you have to make your speed also change. You also have to make you go in a circle. So there is more burden on friction. So, and that is a reason. And if the time passes, A tangential is fine, that guy is constant. But A centripetal, right, is just increasing with time. You have more and more acceleration. Friction cannot provide after a certain time and it just goes off. Do have a look at this. Wait, I did a mistake here. This is not root. This is power 1/4. This is R square. This is 1/4. That is the fourth root. T power 4 na here. I think if you understood this, you'll be able to handle most of non-uniform circular motion. We have more variations, but this is the main base one. Is this clear? Let's see one more like this. Can I go ahead? Any doubts on this? Ansh, Arnav, clear? Taksha, Jainil, Arush, Ojas. Next one. Don't worry about the notes, you'll get the PDF. So let's focus on problem solving. Anything you didn't get not clear, please ask. Similar question. A vehicle of mass m starting from rest has tangential acceleration a is equal to t. T is time. Now your acceleration is not constant. So I'm messing up the tangential also now. Find the speed and distance traveled in time t angle between a net and velocity tangential acceleration is equal to t going in a circle of radius r. At time t. So I wanted to find the angle between this. Find a friction at time t. Let's get that. Idea is the same. You just that you can't use v is equal to u plus at. Try. You got 2-3 minutes. Anyone not clear with the question, please ask me. Just give it a try. I'll get some water and come. Let's see. Any answers? V t square by 2. Right, Ansh. Let's see. First thing, A is equal to T. So acceleration is not constant, so you can't use your kinematics. You got an answer, you can type in the chat box to the co-host here. So A is equal to T, so this is dV by dt is equal to T, so integrate this, so dV is equal to T dt. Limits 0 to V, 0 to T. So you end up with V is equal to T square by 2. So one distance traveled, again integrate ds by dt S is the tangential distance, which is t square by 2. So ds will be t square dt by 2 integral 0 to s 0 to t. So s will be t cube by 6. That was your first part. Second part, what do you want? Angle between a net and v. So when you're going in a circle somewhere here, this was your velocity. We are actually not interested in the velocity part. This was your a tangential. This was your a centripetal. This angle I'm asking. So tan theta is simply a centripetal by a tangential, but a centripetal is v square by r and a tangential is t. And what is v? V is t square by 2. So that becomes t power 4 by 4 rt. That is t cube by 4r. That is your tan theta, everyone. And what else did I ask you? So this would be the direction of a net. The C question will be, you have to find a net. A net is root over a centripetal square plus a tangential square. You can calculate that. And what is friction? Friction is the one who's providing this. F is equal to ma net. And you're done. Since it is not slipping, friction is static. So if at all they ask you when will it slip, then you'll write less than equal to mu mg, but that is okay. You will get a power force and all. It's very difficult to solve. We will leave it. But have a look at the steps. Same thing what it did. Only difference, you have to integrate because a is not constant. Any doubts on the steps? Anything that's not clear, not convincing, please ask. Clear na, Poroja? Pratik? Next one. Vihan, clear with this? Great. Next one. So particle is going in a circle. Kinetic energy of a particle going in a circle of radius r is given by k is equal to b into s square. K is your kinetic energy, b is some constant, s is your distance traveled. Meaning the more you travel, more kinetic energy you get. So they didn't give you acceleration, they gave nothing, they gave kinetic energy. So find the net acceleration, a net, as function of distance traveled. M is the mass of the body. So kinetic energy of a particle as function of distance traveled. So we have no idea how is it starting and all. But as this thing is going in a circle, the more it travels, more kinetic energy it has. So what is the net acceleration as function of mass M? Let's see. First thing, kinetic energy is half mv square. So indirectly, this person gave you velocity here, bs square. So from here, we get v square is 2bs square by m. That is your v square. So what is the use of this? I can find centripetal directly. So a centripetal is v square by r. So that is 2b square by mr. I got my centripetal. Next thing, v is nothing but root over 2b by m into s. What is acceleration? v dv by ds. What acceleration is this? A tangential. You're getting it? You have to find A tangential and A centripetal. A centripetal is straightforward, V square by R. But how do you find A tangential? Differentiate the velocity, V dV by ds. This will be root 2b by m into s, and dv by ds is another root 2b by m. So your A tangential is 2bs by m. You're done. So what is A net? A net is root over A centripetal square plus A tangential square. That would be root over 2b square mr cos square plus 2bs by m cos square. That's it. Clear? So the main idea there is you need to figure it out. The velocity from the kinetic energy. That will directly give you centripetal. Differentiate, you get tangential. Next one. Any doubts on this? Adi, clear with this? Arush? Niharika? Ojas? Clear? Nikhil? Devansh? Next one. Going ahead, Pratik. हाँ देवांश बोलो ना.
2bs square होगा क्या लास्ट में?
2b, yeah. dv by ds is only root 2b mm ना.
ठीक है.
dv by ds is root 2b by m, so we don't take s there. Next one, everyone. Focus, everyone. We have a vertical ring here. Gravity is there. The spring is attached here. This is a movable ring. At this instant, the speed is v, mass is m. This is your center. This angle is 120 degrees. R is the radius. K is the spring constant. Natural length of the spring is r into root 3 minus 1. This is your natural length of the spring. So at this instant, the speed is v. Meaning next moment, what happens, I don't know. But at this instant, the speed is v. Find A centripetal. Find A tangential. Find the normal reaction at this instant. So this is a movable ring on another vertical circular frame. This is a fixed vertical circular frame, getting it? So this big circle is not moving. So that small bead which is there, this guy can slide. So after some time, it becomes like this. After some time, it becomes like this. Hope you're able to visualize how that is moving. It is sliding over it. Now we are not interested what happens after some time. At this instant, find A centripetal, A tangential, and normal reaction. And if you leave like this, after some time, you become like this. So this guy is going on the ring. Let's get this. A centripetal is easy, right? That is the easiest one. Get the normal reaction and A tangential. Try, you got 2 minutes. Step 1, draw RFBD. Before that, can you find the elongation in the spring? That is the first part. You need to find the elongation in the spring. Spring is not a natural length. So how many forces are there on the ring? Spring, normal reaction, mg. There are 3 forces. The forces along the normal will give you normal reaction. The forces along the tangent will give you tangential acceleration. Try. It's a good one. This would be a precursor. Later on, we will handle these kind of questions in work power energy. There, you need to find the speed also on your own. Let's see. What is the elongation in the spring? So if you look at that spring there, it's a little geometry. It's an isosceles triangle. This is R. This is R. So if you drop a perpendicular, this angle is 60 degrees and this is 60. So this would be R sine 60 and this is R sine 60. Means at this instant, the length of the spring is R root 3. So if I take this point as O and this point as A, so OA ka length is R root 3. I think I took that as already A, right? So let's call it B. This is the right now length. So what is the elongation? So elongation will be the current length, which is r root 3, minus the natural length, which is r into root 3 minus 1, which is r. Make sense? So at this instant, the spring was elongated r. Any doubts here? Then at this point, this is your bead here. This is point A here. Remember, the spring force will be towards the spring. So this will be your spring force Kx. X is equal to R. So I'll leave it for Kx for some time. This would be your normal reaction. This would be your mg. Any other forces? The other three forces. What are the angles? Just now we saw this was 90, this was 60, so this is 30. If that was 30, this was 30, that can't be 60. Wait. That is also 30 only actually. No, this I'm not interested. So that is 60, 30. That is 60. This is 60. So this also has to be 60. Total 180 horizontally. So this also is 30. Please check the angles. Anyone not convinced with this angle, ask. This total angle is 120. So obviously this has to be 60. I think maybe I'll write it as 120. That will be more convincing. This is 120. So that has to be 60. That will be 30. So both the angles are 30. Since you're going in a circle, remember there will be a tangential and there will be also a centripetal. There are two accelerations. Now your speed is also changing. You're done. Newton's second law. Apply the force is equal to mass into acceleration. So resolve the components along the normal. I'm resolving in this direction. So I'm choosing this as my x-axis and the perpendicular tangential as my y-axis. So what are the forces in this direction? mg का component mg cos 30. Spring का force kx cos 30 minus normal reaction is mass into centripetal acceleration. How much is centripetal acceleration? V square by r. V is given in the question. Substitute, you'll get m from here. I will leave the solving to you. What about tangential? mg sine 30 minus kx sine 30 is equal to mass into a tangential. There, you know everything here. From solve this, you'll get a tangential. Check your answers. If you got the equations, you're done. So step 1 is to find the elongation in the spring. Step 2 is to draw the free body diagram. Step 3 is to write the F is equal to ma and you're done. Anyone not clear with anything particular here, please ask me. Any confusion, anything you're not okay with this, not convinced, not clear, please ask, don't hesitate, get it cleared. Jainil, clear this thing? I hope that angles are clear. Anyone not convinced with those angles, ask me. Ojas, clear? Arush, Harman, got this? Ignajit, Ishana, Devansh, Arya. Can I go ahead? Next one. Vihan, clear with this? Vihan Agarwal, clear? Next one. Top view. So we have a track like this. This is theta. This is a mu. This is a rough track. This is a rough wall. So we have a block here of mass m. It's traveling with speed u. It enters this rough track. So basically, while it enters with speed u. Then it drags on the wall. And then finally, when it comes out, the speed becomes v. Here the floor is smooth. I'll show you another view of this diagram. Smooth floor. R is the radius of this track. Like this. The track is like this. So our block is like this mass m. It enters here with speed u. Then it drags on the wall. And then when it comes out with v. Making sense, Albertus? This is angle theta. This was a smooth floor. But the wall is rough. So that means when this block is going right, the friction will be backward like this. So because of that friction, the speed changes when it is dragging on the wall. So it enters with speed u and comes out with speed v. Find v. A block enters a curve with speed u and then slides on a rough wall. Because you're dragging onto the rough wall, your speed will change. And comes out with v. Find v. Answer should be in terms of u, theta, r. Anyone didn't get the diagram, please ask me. Picture is clear, right? Hope everyone got the view. Yeah. Try. It's
Sir,
a good
only
one.
the curved surface is rough, ना?
Only the wall is rough.
तो curved surface की वो पूरा wall.
फर्क नहीं पड़ेगा रे.
नहीं फिर मतलब U नहीं रहेगा ना वहाँ पे.
क्यों नहीं रहेगा? फ्रिक्शन
क्योंकि
कितना
अगर
होगा देन?
वो भी रफ रहेगा तो
ओके, नॉर्मल एक्शन कितना रहेगा? If you go parallel to the wall, there'll be no normal reaction. So even if it is rough, there'll be no friction. ठीक है, for your convenience, only the curved part is rough. Happy? कर लो. It won't matter. You will see. There is no one to provide the normal reaction on the wall. Floor पे n will be mg, wall पे n is nothing. Any answers? You got an answer? Do type in the chat box, the co-host. You forgot a minus sign, right? Let's see. Look at your thing. What you got? Nee, Ansh, I think you forgot to integrate. So when this thing is going in a curve, see, so when the block is somewhere here, what are the forces acting on this? You have your normal reaction on the ground, Ng. You have your own weight, Mg. You have friction tangentially. You have one more normal reaction from the wall. And since you are going in a circle, there will be also one centrifugal force, mv square by r. So I'm standing on the block, okay? So my observer is on the block. So the observer is on the block and you're doing the problem. So A tangential will be this way. So here, the reason why you're getting normal reaction on the wall, and remember this distance which you're traveling, theta, and this is r, so the total distance S is equal to r theta. So normal reaction on the wall is due to the centrifugal force, mv square by r. So this is providing the friction. So friction on the wall is mu into n wall, which is mu mv square by r. And this friction on the wall is responsible for the tangential acceleration, mat. So we get mu mv square by r is mat. So we get A tangential is mu v square by r. Now here, be careful. So A is minus v dv by ds. Why minus n? Since it is decelerating. Since v and a are opposite, you get A is equal to minus v dv by ds since it decelerates. So if A and B are in the same direction, then it will be plus v dv by ds. This is equal to minus mu v square by r. One v will cancel. You will get minus dv is equal to mu ds by r. Integrate on both sides. This will go from u to v and this will go from 0 to s. This will be v minus, wait, I forgot a v there. This is a v there in the denominator. That will be minus ln v. Limits will go from u to v. This will be mu s by r. So you will get ln v minus ln u. So that will be ln V minus ln U, send minus n, that said mu s by R. This will be ln V by U, but S is nothing but R theta. R cancels off. You get V by U is equal to e power minus mu theta. V is equal to U into e power minus mu theta. This is your velocity as function of angle. And if you look at the function, right, see what is happening. The faster you go, more centrifugal force you have. If you have more centrifugal force, you have more friction. If you have more friction, means you have more deceleration. Means if you have more deceleration, your speed will decrease more. If your speed decreases more, n will decrease more, n decreases more, f will decrease more. You're getting what is happening? The function is killing itself. The function is killing itself. This is called decay functions. These kind of functions are called decay functions. The higher the value will, make sure it will change its own value later on. So look at this thing. This is a decay function. So generally, whenever you have these kind of functions which kill themselves, we call them exponential decays. You get answers in terms of e power. So mathematically, it will be quite useful to remember. Sometimes you'll see that. Have a look at this. Clear with this? Any doubts on this? Clear or no? Adi, got this? Check out the integration. I think at this point, right, circular motion got over, then it kinematics only does. Be careful, this much integration should be quite comfortable. Next one. Let's see how they'll frame an advanced question. We have a cylindrical rod. We have a rod like this. This is a rod with cylindrical cross section. Someone started rotating this with alpha. It's a constant angular acceleration. Gravity is there. Now on this rod, someone kept a ring. So this is a ring of mass m. Which just fits over the rod. Are you able to visualize how is the diagram? So this is the rod, this is the ring. So the ring is just, is balancing on the rod. Able to visualize? It's like your bangle or something. If you keep it there like a ring, it is just holding on that. Now what you did, you started rotating this. So now you tell me, if I rotate this, what will happen? At some point, this ring will come out and fly, isn't it? I hope you're able to visualize. If you keep a ring here and if you start rotating this, at some point, the ring will just fly outside. So this rod is rough. So the coefficient of friction is mu. This distance is r. Okay? So initially system is at rest. And once the rod starts rotating with an angular acceleration, to give an analogy, right? Think of like this. You can take a coin, right? Maybe take some coin and put it on your fan ka blade. Put it on top of your fan and switch on the fan. What will happen? For some time, the coin will stay on the fan, but maybe in a few seconds, the coin will fly out. Isn't it? Something similar happens here. Initially, system is at rest. No one is rotating. Then you start rotating with omega. So the question is, find the time when ring slips. The second part of the question is, so if I ask you this as a paragraph, if you replace the ring with a square frame, if ring is replaced by a square frame, Find time when it slips. Meaning this is how it would look. Exactly same thing, but only difference the shape. It's a square frame. Same mass, same friction, same R, everything is same. There. If this was an advanced paragraph, this is how I'll ask you 2 questions. First, I'll put a ring and I'll ask you when will it slip, and then I'll put a square frame and then I will say when will it slip. I hope the question is clear. Anyone didn't get the diagram, please ask me. Think. It's a good one. Let's get the first part. Think about it 2-3 minutes, then I'll give you some ideas. So you kept a ring there. Initially, it is just hanging. Once you start rotating, after some time, the rod will come here. The ring will come somewhere here. It starts sliding, meaning once you have enough velocity, the ring will start sliding outside. The question is, after what time will the ring start sliding? Think. 4th root alpha mu r g no, just that's not the answer.
So not fourth root. I didn't write fourth root.
No, alpha square is not the answer. I know.
Okay.
Let's see. Vihan, I'm not sure about that. देखना पड़ेगा. Power 4 आया क्या? नहीं आएगा रे power. Maybe you might get it. Let's see. Think others. I'll give you a minute more and then let me explain you a bit more about like what's happening. But try to figure out. It's okay if you don't get a question. That's totally fine. Think, at least get something wrong. नहीं पूरा अच्छा. Let's see. First, let's see how this rod actually would be, okay? Imagine if there is no rotation, how it would look. If there is no rotation, this blue one is your rod, the ring will look like this. Meaning the topmost point of the ring will be lying on the rod. You're getting how it is? Meaning, if this was the rod, and if you keep the ring here, won't it be like this? The entire weight will be balancing it, isn't it? So this cylinder will be touching the topmost point of the ring. So the FBD would have looked like this. So this point, you'll have a normal reaction Ny, which will balance the mg of the ring. If there is no rotation. Suppose if there is only rotation but no gravity. So I'm trying to show you both separately. If there's no rotation but gravity is present, sorry, if there is a rotation and no gravity, then what would happen? So the ring will just float here if there's no gravity, and suddenly if you pull, what will happen? If you suddenly pull, it will hit horizontally, right? So your diagram would look like this. So this would be the rod, and this ring would look like this. So it will be touching here. So this will provide the normal reaction Nx, and this will be responsible for your tangential acceleration. Don't forget, it is having an alpha, which is R alpha. Make sense? And here Nx will be equal to mass into A tangential. So if you have both of them, now if you have rotation plus gravity, now the rod won't touch on the top, rod won't touch on this thing, the rod will touch somewhere in the middle. So the ring would actually become like this. This would be the point of contact. Make sense? Think about it. If I take a circle and another circle touches there, two circles will touch only at one point, right? I hope that is making sense. If you take a ring inside a ring and if you make them move, there's only one point of contact. So the normal reaction will be like this. There will be one component Nx and there will be one component Ny. So there's one point of contact. And this normal reaction will be resultant of root over Nx square plus Ny square. Is that making sense, everyone? So that ring on this cylinder will be touching somewhere at an angle here. It won't touch on the top. It won't touch horizontal. It will be in the middle. So that one point of contact, normal reaction will generate two components, Nx and Ny. Ny is balancing the weight of the ring, and Nx is, creating the tangential acceleration. Any doubts on this? Please check out this page. This is the main idea, the whole visualization, like how is this ring actually, staying on that rod. Any doubts on this page? Anyone not convinced with the diagram, please ask. I try to keep it as simple as possible by splitting into two parts, with rotation, without rotation. So if you have both, you have to do both. So the rod will be somewhere in the middle. Clear? Now let's draw the FBD. Now look at all the forces here. This is your Ny. This is your balancing mg. This is Nx. That would be giving your tangential acceleration. Now remember, because you're trying to slide outside, there is a centrifugal force, m omega square r. And there is also friction, no? There is a friction between the ring and the rod, which is actually trying to stop it from going. There is a friction also here. friction is towards the, I'll just write here, okay, friction is here. It's actually at the point of contact. That's it. These are all the forces. So Ny is mg, Nx is m into A tangential. A tangential is mr alpha. So normal reaction is root over m square g square plus m square r square alpha square. Omega is nothing but alpha into t. You're done. So who is stopping you? Friction. So friction is equal to m omega square r. But I know friction must be less than equal to mu normal reaction. So this is omega is alpha t ka whole square r must be less than equal to mu n, which is when m comes out, root over g square plus r square alpha square. M cancels. We get t square is less than equal to mu by r alpha square g square plus r square alpha square ka root. Again root will come, so t must be less than equal to root over mu by, you could have sent it inside and made power 4. So you would have got power 4 if you have done that. Maybe you did that only. Yeah. This is the time when it slips. So here remember omega final is omega initial plus alpha t. So initially omega is 0, so omega final is alpha t. So here basically the friction on the rod is towards the center. That is what is stopping you from slipping. There, check it out. So the normal reaction, there'll be two components of it. That was the whole catch in the problem. And Nx is which way? Nx is along the tangent. Do look at the FPD. Question is still not over. What if you replace this with a square frame? How does that affect the problem? Keeping everything same, if I just change the shape, will it be any change or it's the same thing? Think, I'll give you a minute or two. Right, Purvaja. So how does that affect the problem? Let's see. There will be, right, Purvaja. Then it will affect the problem. Right, Vihan? It does affect the problem. Dekho, what happens? Now, when you put a square frame, you did something. Now, this is the cylinder, and when you put a square frame like this, it will touch 2 points, right? Now, there's not one point of contact. You're touching 2 points. So you get 2 normal reactions, means you'll get 2 frictions. But the values will remain same, but something happens here. Look at the difference. This would be Ny, which will balance Mg. This would be your Nx, which will provide your tangential acceleration, R alpha. So far the story is the same. The difference would be this. So when you draw this FBD of this ring, there is Ny, there is Mg, there is Nx, which is making you go in a circle. Now you'll have 2 frictions, Fx, and there's also one more friction, Fy. I'll just put both here only. So now you guys tell me, is a square plus b square ka root same as a plus b? It's not same, right? And the centrifugal force would be outside m omega square r. This is what happened. Now there are 2 frictions which are stopping you. Fx plus Fy is m omega square r. Fx is mu nx. Fy is mu ny. And we know omega is equal to alpha t. So this would be mu mg. This would be mu m r alpha is equal to m alpha t whole square into r. M gets cancelled. So we get mu into g plus r alpha by r alpha square ka root. This is your time. So can you tell me which will slip first, the ring or the square frame? See, nx and ny didn't change. Understand one thing, nx and ny didn't change. But in the first case, you had only single normal reaction, n. So now you need to ask yourself, which is bigger? Is a plus b bigger, or a square plus b square ka root is bigger? Which one is bigger? A plus b is bigger. If a plus b is bigger, that means the friction Fx plus Fy is bigger. If you have more friction, it will take more time to slip. So the square frame will take more time to slip outside than the ring. Are you getting the difference, everyone? In the previous problem, see, friction, right? If you have only one contact, you get only one friction. One contact gives only one friction. So you have to find the net normal reaction and then use F is equal to mu n. But if you have 2 contacts, you get 2 frictions. Frictions both will add towards center only, they're adding up. Since nx plus ny is greater than root over nx square plus ny square, the friction is more in the square frame ka case, so it will take more time to slip. Is this making sense, everyone? Can you see, changing the shape can alter the whole problem. So the main idea here is to realize there are 2 points of contact. So there will be 2 frictions. Please have a look at this. Ask me if you're confused. This would be a pretty good advanced paragraph question. A part and B part. Clear? Others, any doubts? Anyone not convinced with this? Clear na, Poroja? Got this, na?
Sir,
Devansh.
could you explain the direction of nx?
Nx here, na? देखो. If this is the ring there, ये ring circle में जा रहा है ना? Getting it? So this ring I'm not able to draw properly. It is like this. A ring ऐसा touch करेगा. It is touching here, right? So this nx will push like this tangentially. Circle में जाएगा nx. You're getting it? It is like if you take the ring here, this is the ring and this is the rod. देखो ना, nx will push this way. You're getting it? So the force will be through this gap. समझ में आ रहा है? मतलब ऐसा होगा force nx tangentially. Okay. There. That is about non-uniform circular motion. So next class, when we catch up, we will do something called radius of curvature. We will be discussing the last week of paper also now. So radius of curvature is there. That's a small part. Mostly we should wrap up in the first half of the class, and then we will start off with work per energy introduction next class. So you can start solving questions. Circular motion is almost done. The radius of curvature is small part. We will see that later on. Okay, now let's see the last week of paper. So we have done almost 32 questions. So please do resolve the notes first, and then whatever material you're solving, do start solving. Okay, with that we will wrap up for the day. So those are doubts in the class notes or any other thing, you stay back. First we will see any doubts in the class notes, then we'll see your paper cut doubts, and then we'll see if you have any other personal doubts. So, yep. So any doubts in the class notes first you can ask. If you have no